Now we're going to talk about some of the specifics of replication. There is an enzyme called DNA polymerase III, and it reads the DNA and creates the complementary base pair, the new copy. And it has the ability to continuously read DNA, but it has to be in the 3' to 5' direction. And when it does that, it travels away from the replication fork, and it creates the new DNA strand working from a 5' to a 3' direction. Now, the DNA that runs from the fork in the 3' direction is referred to as the leading strand. And this is not a problem for DNA polymerase III. It just continues to add one nucleotide after another. And it can start using only one primer. That's that RNA primer, remember? But here's the problem. Because of its directional dependence, the DNA polymerase III can only read the other DNA strand in short sections, traveling in the 3' direction, and this is very important, toward the replication fork. So this strand is always called the lagging strand. Remember, the order of the nitrogen bases is determined by complementary base pairing, of course. Now, what are some of the challenges of lagging strand replication? Because remember, with the leading strand, it was just adding one nucleotide after the other. Well, first of all, there has to be a 3' hydroxyl group to form the phosphodiester bond with the new nucleotide. And this is supplied by the RNA base added by primase. The lagging strand can only be replicated in small sections due to the 5' 3' directional dependence of DNA polymerase III. Small sections are called Okazaki fragments, and the replication process has to be repeated several times. And remember, while the leading strand can get away with having only one primer, each of these Okazaki fragments must have its own primer. Then DNA polymerase I has to go back and replace all the RNA primers with DNA. Then the gap between Okazaki fragments must be repaired and sealed, and this is done by an enzyme known as DNA ligase. I really want you to study figure 1616 and watch the animations that are on the PowerPoint, okay? Proteins participating in DNA replication form a very large complex called the DNA replication machine. Please notice that the enzymes that we have been discussing, many of them are summarized in table 16.1.